So good morning one and all. I thought I will be showing you the video clipping of a ball mill. So this is the shell side and where the spherical balls are kept. And when the balls are rotating, see how the crushing is taking place. Suddenly you find that white color powder will be coming out from between. That indicates that the solid products, solids which are there inside this grinding medium, they are being crushed. So now you see white color powder. So this powder is mainly the product which has been crushed in the ball. In slow motion, he is showing us how the balls rise and the fall. Here are all the grinding medium of uniform sizes. Point of breaking, the contact. So this is one type of grinding where we can see the ball mill. So now next let us go for the next descriptions. After seeing the equipments, we have seen the equipments 2 times also. Now we have some remaining part of theory. Let's complete it today. So equipment operation, how does we expect that any type of equipment, how does it has to operate and what are the prerequisites for it and how does it affect our product and energy consumption, etc. We are going to see today. For the proper selection and economical operation of the size reduction machinery, attention must be given to many details of procedure and of auxiliary equipment. Proper selection. I said in the beginning only, people will come to us that they have some types of ores and for them we are supposed to decide which type of machine we are going to give to them. So first we should do the analysis of the product of their ore and then find what is the concentration and how the elements are distributed and what is the compressive strength, and based on that how we are able to break them. Do we have to suggest a hierarchy of size reduction equipments or one equipment is sufficient, and in that also we are supposed to predict the power by means of conducting the experiment and using the 3 empirical laws, and then we have to compare it with the actual power consumption and then we can give it to him. So economical concept will come only when the power consumption is we have established. So we should see that the given machine should consume less amount of power and it should be able to perform the task in a stipulated amount of time, and the product which is obtained is also having good concentration of our sizes. Since we are dealing with heterogeneous materials, there will be size variation there in the product. So, but we are supposed to select that machine which will be giving us maximum percentage of the product of our desired size. That should, if we are able to do that, then of course the process will be economical process. And attention must be given to many details of procedure and of auxiliary equipment. Now, what is the meaning of auxiliary equipment here? Now, first point already we have assumed that in any type of the crusher, if you take it, as far as possible, if you try to avoid the foreign particles, it will be a good thing. Means what? suppose if you are using limestone, you see that only limestone ores are sent to this system. Means for prior we should have a purification system like float flotation or whatever it, any type of device which you take it, that should be before only. So, and apart from that, we have seen that in that single roll tooth crusher where leather particles are used. So, we are supposed to reduce the temperature of the particle, because if you don't reduce the temperature of the leather particles, there will be an elongation will be there, and the size reduction equipment may not function properly. So, you are supposed to cool it. So, apart from that, our main equipment, any other equipments are needed for satisfactory working of this particular machine or for this particular task are termed as auxiliary equipments. Okay, so we should have a thorough knowledge of all those things which are needed for a given task. A crusher, a grinder, or a cutter cannot be expected to perform satisfactorily unless, first point, the feed is of suitable size and enters at a uniform rate. This is very important point. As you know, as we just discovered, suppose you take the case of the Blake type of jaw crusher. Yes, the pivot is at the top, which will be putting a restriction that if the particle size is able to pass through the clear opening, then only it will be accepted for crushing. If not, crushing will not take place because the particle cannot enter into the system. So if the operator does not take care of it, means what, he has to screen the feed first, and then feed of appropriate size only we are supposed to send it. Similarly, in our laboratory also, when you come to do the practical, you will be strange. You will see that whatever the feed which we are giving to us, it will be of same more or less uniform sizes. But after crushing is over, you are going to give different types of particles. Okay, so first step is what? The feed of appropriate size should be accepted, should be sent to the mill. Whatever the mill you are going to use it, the mill decides this, the mill dictates us. If you do this, what will happen? Then of course the power consumption will be kept in. And second one is, of course, I said that M dot. How you are sending the particles into the system is very important. If you dump all the solid particles at the stretch, crushing may not be uniform, and there can be some erratic variations because you have added all the particle at once. The power consumption may increase tremendously at the particular point. Once crushing is over, the power will be less. So we may not get exactly how much amount of power is required, because I said that we are comparing two things. What we are comparing? We are comparing actual power required by means of energy meter. So in the last videos, we have seen what is an energy meter, how we are going to take the readings. We have seen this. So actual power we know, but how this power is predicted by means of three laws is very important, because we can't expect everybody to be a skilled person or an educated person. So the person who is purchasing this, so we are supposed to use any one of the law which is verified. Based on it, we should estimate the power. Okay. So for that purpose, m dot, because in that empirical equations, P by m dot is there in the left hand side of the equation. If m dot is increasing, what will happen? The value of the fraction increases. If m dot is decreasing, what will, sorry, the m dot value is increasing, what will happen? The value of fraction will decrease. And m dot is decreasing with the value of the fraction, what will happen? It will increase. So in order to avoid this kind of things, let us put m dot as constant. Now the point is how to put this m dot constant in the industry. This is put constant by means of conveyor belt. So you try to have a conveyor belt on the top which is discharged into the jaw crusher. At the same time, bottom, when the particles are crushed, they are coming out and they are falling from the bottom. They should also have a conveyor belt, so that as soon as the product crushing is over, it falls in the belt, and then the belt immediately takes it out from the vicinity of the crushing zone to some other place. If such a thing is occurring, what will happen? Then crushing will take place satisfactorily. So m dot is kept constant in the industry, because in the industry we may deal with tons of materials per hour. Keeping human beings will be very difficult. So hence the conveyor belts, if they are loaded properly, then definitely we can keep m dot as constant. So RPM of the conveyor belt is very important to decide the value of m dot. So if the RPM is more feed is transferred. More feed is transferred means what? The crushing should also take place accordingly. If not, what we should do? We should reduce the RPM of the conveyor. So if you reduce the RPM of the conveyor belt, slow dosage of feed will be there to the machine. Then the second one, the product is removed as soon as possible after the particles are of the desired shape. So as I said just now, even the bottom also you are supposed to keep a conveyor belt. So we have seen the video of a jaw crusher, you have seen the video of a roll crusher, you have seen, but this problem is there only for the continuous mills, where we add the feed from the top and we take the feed from the bottom. But suppose if it is a batch process, of course we charge the material into the ball mill, close the lid, and then wait for some amount of time, and then we stop the machine and then take out the discharge. So there we don't have this problem. But in case of a continuous mill, as we are sending the feed from the top, if you are not taking the product from the bottom, what will happen? The pile up of the product enters the zone of crushing, and unnecessarily it will be blocking the materials to come inside the system. As the height of the pile increases, what will happen? It completely fills the machine, and only the crushed product will be subjected for crushing. So energy is given to the machine, but crushing is not taken. So hence, concept is what? As we are sending the feed from the top at a constant rate, at the same time, you try to remove the product as it is falling down by some mechanism. Usually conveyor belts are used. Third one, unbreakable materials is kept out of the machine as far as possible. Try to separate ferrous materials from non-ferrous material, and elements hardest materials from other. So means what? Visual inspection of the feed is very important. It's not like that we blast the ore and then get everything and then put it to the crusher. No, we are supposed to visually inspect it, and then we are supposed to see what are the compressive strength of the material. So based on that, we are supposed to separate them. Means what? Primary crusher is there. We may be using primary crusher to crush any type of thing, but the product which is obtained, either you separate it by means of sieving or by means of flow flotation or any, or by means of using a chain belt conveyor where you can use magnets, so you can separate non-magnetic materials and magnetic materials. Whatever the methods are available in metallurgy, you can do it. But for us, what is important is visual inspection of the feed is important. The operator has to satisfy himself that the feed is of all appropriate size and it belongs to one type of material. Then only we can expect some satisfactory performance from the machine, and economically also that will be feasible for us. If not, difficulties will arise. As you know very well, that whenever in the break type of jaw crusher, if a foreign particle is entering, by the way, what is the meaning of foreign particle? Particle whose compressive strength is different from that of the feed. It's called as a foreign particle. If any of the foreign particle is entering, what will happen? The leaf spring will go back, and then the energy is stored in the flywheel, and the particle falls down. Then again we have to stop the machine. The operator to release the spring. Then again the functioning will take place. So means what? Our productivity is different. So before that only, we have to inspect the feed. It should be of same sizes. Uniformity has to be maintained the sizes, and at the same time, see that the nature of the materials are same. Then the fourth one, in the reduction of low melting or heat sensitive products, the heat generated in the mill is to be recovered. So as I said, as we have seen this, that suppose why the point is why the heat is generated. Because as we have seen in the beginning classes only, when we are going to apply some force on a particle, what will happen? The particle will be storing the energy as we are storing the energy in the spring. When you keep your spring in your hands and then apply some force, what will happen? Energy will be stored in it. And once you remove the hand, what will happen? The energy will be released and spring will gain its own original dimension. Here also the same case. Within the elasticity, the solid particles, when you apply some force on it, or it will withstand it. And then as you go on increasing, a stage will come that beyond the rupture, then what will happen? If you apply 1 Newton or so, it will not resist, it breaks into pieces. But what will happen to the energy which is absorbed inside the system, that will come out in the form of heat. So suppose if you are dealing with the heat sensitive materials and materials which are having a tendency of melting because of the heat, then care must be taken that as heat is produced into the crushing zone, it will be removed by means of pumping externally circulating the chilled water, or pumping liquid nitrogen or liquid solid carbon dioxide. We are supposed to inject into the system so that we will reduce the temperature of it. Heaters and coolers, metal separator, pumps and blowers and constant feeders are therefore important adjunctions to the size reduction unit. So these are some of the auxiliary equipments which are needed. Sometimes we are supposed to heat the material, we are supposed to cool the material, and the metal separators are very important, because if the metal separators are not there, if they enter the system, suppose if you are using limestone and any iron particles are entering, the machine will be damaged. So we are supposed to remove them. Similarly, pumps and blowers. So if you see the micro atomizer, so where the shaft we are carrying 2 fans, means what? Blowing of air inside the system is very important. So when you blow air, what will happen? The air will be passing through the compression zone, and the product which is being crushed, what will happen? The smaller particles cannot resist the drag force, they will be carried away. Means what? A mechanism is there to remove the crushed product from the system on a continuous basis. So when you want to have this kind of thing, so you should have an external blowers also. Then concentrate feeders are your conveying system. So these are, we require them for satisfactory functioning of our size reduction equipment. Factors to be considered in specifying a size reduction equipment include the energy efficiency and the environmental issues. So the most important thing, as I said, is because in the primary things, the energy efficiency may be high in the primary crusher. But if you take the case of fluidized energy mill, how much amount of energy we are giving to it? 8 atmospheres of steam or air we are injecting. So for the creation of 8 atmospheres of steam or 8, how much of energy we are going to expend? That is very important. And what is the size reduction which you are obtaining? It is very small because of only one thing. The size reduction in the fluidized energy mill is restricted only to interparticulate attrition, only that one. So because of that turbulence only, you are expending huge amount of energy. So their energy efficiency will be very less. But in case of a lake type of jaw crusher, because we are dealing with coarser size of particles, crushing may be successful and we may able to catch the bigger particle and then apply the force. So there the efficiency may be more. But as we try to go down, what will happen? Efficiencies are decreasing. And not only that, the most important thing is the sound which is emanated from the system is also very important, because we have to consider a term called ergonomics. Ergonomics is a branch of science which deals with the study of human psychology at the workplace. So in the operator may be in the house may be different, in the workplace may be different. So we are supposed to deal these factors. Apart from that, we are dealing with the materials which are crushing. So there can be fines which be going out from the atmosphere, which may go to the atmosphere, and they may be contributing to a term called as SPM, suspended particulate matter, or air pollution. So all these matters will be affecting. So as far as possible, when you are using a size reduction equipment, you see that you use proper ducting system so that there are sound absorbers are there. Sound is not emanated fully to the atmosphere or to the surroundings, and the operator is also safe. He may be having eardrums or a protective coating so that the sound may not destroy his eardrums. And the second one is environmental issues. We should try to reduce pollution which is contributed from our industry to the atmosphere. So in the last class, we have seen what is an open circuit grinding or a closed circuit grinding. So let me show you the diagram also once. Yeah, this was the diagram. Let us have a quick revision before we start the theory part of it. So in case of a closed circuit grinding, we are having a hierarchy of size reduction equipments are there which are operating on a serial fashion. So first one is the gyrated crusher or the primary crusher. The feed enters from here, and after entering, what will happen? We have taken all precautions that foreign particles will not enter to the system, and the feed will be of appropriate size. And the next one is what? The M dot is also kept constant. So hence the working of this machine will be satisfactory. Then after crushing is over, we are going to get materials of different sizes. Now they are subjected for this screening first. So what will happen? Some particles may not pass through this like the second line. So what will happen? They will be called as coarser particles. So these coarser particles are sent back to the system. Whereas the particles which are passing through this line, this is the screen actually, they are called as intermediates. So these intermediates are now sent to the rod mill, and from there, what will happen? The outlet will be taken out. Whereas the particles which are passing through the third screen, they are called as fines. So intermediates, after passing through the rod mill, they will become fines, and these fines now will go to the ball mill. Where in the ball mill, of course, we are going to add the water. We know that the function of adding the water to the ball mill is only one thing. We are supposed to see that the void fractions are filled with the water level so that the particle will not hide in between the gaps. It will come to the vicinity of crushing zone. And after the crushing is over, the liquid is sent back to the centrifugal classifier. A classifier is a device which is used to separate the inlet solid particles into two sizes. One is smaller size, second one is heavier size. And here the medium is water. So what will happen? The oversized particles are now sent back to the repulper, where we add additional amount of the water and then send it back to the ball mill. Whereas the small size particles along with the liquid, they'll be coming out. So this can be dried up, and then the product can be used elsewhere, and the liquid can be recycled back. So, but what is the significance of this flow sheet is, we send the feed from here, and unless and until its size is smaller, then only it comes out from the system. Otherwise, till then it will be present inside the system, and hence the name is called as closed circuit grinding. So this kind of diagram we have seen in our manufacturing of cement, 4 compartmental tube mills. Unless and until the product size is 200 mesh, it is not coming out from the system. The clinker size is 3 to 8 centimeters, but unless until its size is reduced to minus 200 mesh, it is present inside the system only. So this is the diagram of a flow sheet for the closed circuit grinding. Yeah. So let's see the theory part of it. The open circuit and closed circuit grinding. So what is an open circuit grinding? An open circuit grinding is a grinding in which we add the feed and crushing is over. The product is separated, finished. We are not least bothered what we are going to do with the oversized particle. We are least bothered what is happening to the fines, but crushing is completed. In many mills, the feed is broken into particles of satisfactory size by passing it once through the mill. So when no attempt is made to return the oversized particles to the machine for further reduction, the mill is said to be operating in an open circuit. So this is the definition of open circuit. So once you charge the feed, whatever the jaw crusher or any type of mill, we take out the feed and then we are least bothered, because I said in the beginning also, if you are doing the experiment with the jaw crusher, majority of the particles will be there on the topmost screen. This observation is very important. Suppose if you are doing a roll crusher or a ball mill, majority of the particles will be there in the pan, means what? Crushing is completed, they will fall here. So hence, if you are not taking any care to take out that heavier particles with the particles which are not crushed to the satisfactory size, again if they are not recycled to the mill, then of course that will fall under the category of open circuit. Suppose if you are carrying them again to the mill, that oversized particles, then it is called as a closed circuit grinding. Now, this may require excessive amounts of power, for much energy is wasted in regrinding the particles that are already fine. So what will happen here, unless and until you are not separating the particles, if you are again putting them, say for example in the previous flow sheet, you think that in the gyratory crusher we are putting the feed, the entire feed is now sent to the rod mill, the entire feed is now sent to the ball mill, then what will happen, whatever the fine particles which are formed in the crusher, in the prime gyratory crusher, they will be unnecessarily occupying the space in the rod mill, unnecessarily occupying the space in ball mill. Already the sizes are small, so energy will be wasted. So that is important. So hence, screening is very important, so that the fines which are obtained, they will be sent, they will be bypassing the rod mill and they will be going to the ball mill, where further crushing will take place. And what will happen to the fate of oversized particles? That will be recycled to the mill. That is it. Because once the oversized particles are coming out from the gyratory crusher, if you send them to the rod mill or ball mill, it doesn't make any sense, because they will be occupying more space and more energy consumption. So we can't control the factor called as energy consumption. Our power consumption is not at all economical. Now this may be require excessive amounts of power, for much energy is wasted in regrinding the particles that are already fine. If 50 mesh product is desired, it is obviously wasteful to continue grinding 100 to 200 mesh. So what is the meaning of it? Your design is you require 50 mesh, and if unfortunately if you are finding that the particles are 100 and 200 mesh, what is the need for it to stay inside the system for further crushing? It is waste. So we are supposed to separate it. Thus it is often economical to remove partially ground material from the mill and pass it through a size separation device. What is the size separation device? Our screening is a size separation device. Screening is a unit of operation in which particles are separated based on their sizes. So immediately if you see the diagram, if you remember the diagram, as soon as the product is coming out from the gyratory crusher, it was going to the screening first. So in the screening, the first line is sent back to the gyratory crusher, the second line is sent to the rod mill, and the third line, where the sizes are very small, it was sent to the ball. So that is important. The undersize becomes the product and the oversize returned to the regrinding. Very good. The separation device is sometimes inside the mill as an ultrafine grinder. It's a beautiful statement. In ultrafine grinders, micro-atomizers, I said that we are blowing air, fans are there. As they are rotating, fans will suck the air from the atmosphere and they will be blowing into the system. But what is happening? They will be carrying only small particles. Small particles will come from B to A, whereas heavier particles will move from A to B. See the direction of the vein they are coming out. When they will come out, because air can come out through a narrow gap, no problem. But if the size of the particle is small, then only it can pass through the free space which will be carried by the air. That is important. Or in some more outside the mill. Closed circuit operation is the term applied to the action of a mill and separator connected so that the oversized particles are returned to the mill. So that is the definition of the closed circuit grinding. Unless and until the size of the particle is less of the desired one, it will be present inside the system only, so that we have a concept of recycling the oversized particles and sending the smaller part fines to some other place where further reduction is taking place. Then, for coarse particles, the separation device is a screen or a grizzly. Now, grizzly we are going to see in our 4th unit. Or you might have seen whenever they are constructing a big apartment, they will be bringing a a cylindrical like of thing which is in the screen shape, okay, and which is having a sloping bottom, and they will put the concrete there inside it and they will try to rotate it. What will happen? Fine particles will fall from the peripheral discharge, whereas heavy particles will roll to some other place. So for a heavy, when they construct an apartment or this thing, they will bring a grizzly here. Okay, so screen and grizzly means what? The screens will have moderate openings, but grizzlies will have larger openings, and it is robust in construction. The diagram of a grizzly will be studied in our 4th unit. Yeah, for coarse particles, the separation devices is screening and then grizzly. For fine powders, it is some form of the classifier. Classifier is a device which is used to separate the solid particles into two ways. The first one is two sides. The first one will be the overflow, the second will be the underflow. Underflow will carry larger type of particles, overflow will be carrying smaller type of particles. And here we are going to use water as a sorting medium. So the design of a classifier is there in our unit number 5. Don't worry about it. So what is the feeds are here? Feed is consisting of liquid and it will be carrying solid particles of two sizes. The first size particle is less, the second size particle is more. So when you send this feed to the classifier, what will happen? Because of the sedimentation, the larger type of particles will sink to the bottom of the container, and along with the liquid it goes out. Whereas the overflow water whichever is in the top, what will happen? That will be carrying fine particles or smaller size particles, and they will be going out. So this is the meaning of a classifier. Suppose on the vice versa, we have a feed consisting of liquid and solid particles. All solid particles are going from the bottom and the liquid is going from the top. This is called as a clarifier. This is called as a clarifier. So if you remember the beneficiation of rock slurry, okay, see in the manufacturing of cement, these two definitions we have studied there. No problem. A typical set of size reduction machines and separators, A typical set of size reduction machines and separators operating in closed circuit grinding is shown in the diagram which we have already seen. The product from the gyratic crusher is screened into 3 fractions. Now he is describing the same diagram. 3 fractions, fines and intermediates, and the oversized particles. The oversized particles are sent back to the gyratic crusher as we have seen, and then fines are fed directly to the final reduction unit, a ball mill. So in this case, because the size is measured in terms of screens only, he is suggesting to go for ball mill. Suppose if you are interested in reducing further size, then we may have to go for microatomizer, addition of microatomizer, or the addition of fluidized energy mill is an essential one. So it all depends upon what is your size of the final product. That will decide the number of size reduction equipments to be added so that you get particles of your desired size. In the arrangement shown, the diagram, the ball mill is grinding wet. So why it is grinding wet? Because water is present there. Okay. Then water is pumped through the mill with the solids to carry the broken parts into the centrifugal classifier. The classifier throws down the oversize into the sludge, which is repulp. Means what? Again, we are supposed to add the requisite amount of the water and then make a pulp of it, uniform concentration, and then send it back to the ball mill with more water and return to the mill. The undersize or the product emerges from the classifier as a slurry. Slurry is nothing but solids and the liquid. Okay, solids are very small and then concentration also very less. What is the sludge? Sludge is also same thing, but the concentration of solid particles is more. So the volume of the liquid will be less, the volume of the solids will be more, the size of the particle is same. But what is a paste? Same sludge, but if the particles are able to stick to one another, they are exhibiting the character of adhesiveness or cohesiveness, then it is called as a paste. Slurry containing particles of acceptable sizes, so that will be taken out from the ball mill followed by classifier and from the retake. Although screens are simpler to operate than classifiers, yes, because in screening it's a very simple thing. Arrange all the screens. How do we arrange all the screens? Arrange them in such a manner that as we go from top to bottom, the mesh numbers are increasing, the clear openings are decreasing. You keep it on a vibrator, add the feed, and then guide with your hands. The screening is over, and you can weigh them and then find the value of d bar. But suppose if you are getting the classifier, you are getting a slurry, isn't it? So next step is what? After you get the slurry, you are supposed to separate the water. Again, nuisance. So how to separate the slurry to a solids? You can use a centrifuge or you can use a dryer. So if you use a centrifuge, what will happen? Again, you are expending energy. You get wet mass, and this wet mass again put into the tray dryer. Then you get the powders, and then you try to measure the sizes of the particles by screening. Okay, so it takes some amount of time. Sorry. Although screens are simpler to operate than the classifiers, they cannot economically make separations when the particles are smaller than 150 to 200 mesh. So what will happen is very important. So if you see the Taylor standard screens, the basis is only 200 mesh. So if you have a mechanism of developing more screens, then of course that will be easy. But remember one thing, as the size of the particle is decreasing, separation will also decrease, because the main component of separation in a screen, how the particles are falling is because of the free space. They should enjoy free space. When they have free space, what will happen? They have movement. They can go from here and there, and they will find the clear opening, and through that they will fall down. But suppose on the vice versa, if remember all the particle sizes are very small and the clear openings are also very small, then how difficult it is for us to send do the sieving. This is very important thing. With this, I will understand in our unit number 4. Don't worry. It is the overgrinding of precisely these fine particles that results in excessive energy consumption. Closed circuit grinding is therefore, you will say that closed circuit grinding is the best option, because we are separating the particles as they are formed. Yeah. So, of most value in the reduction we find to ultrafine sizes, which demands that the separation be done by wet classifiers and air separators of type described in your next chapter, that is unit number 4. We are going to study them. Energy must of course be supplied to drive the conveyor separators in the closed system. Despite being this, the reduction in the total energy requirements over open circuit grinding often reaches to 25%. Very beautiful statement. He says that the amount of energy consumed in open circuit grinding is 75. Then, amount of energy consumed in closed circuit grinding is 75. The amount of energy consumed in open circuit grinding will be 100. Why? Because we are not making any attempt to remove the fines after the crushing is over. So they are unnecessarily blockers. They are blocking the volumes or the crushing areas. They are not allowing other particles to come, because they are also having some amount of mass. And if the concentration is increasing, the losses will be more. So finally, though we are having so many equipments are there in the closed circuit grinding, if you see the net energy consumption, it will be 25% less than that of the open circuit grinding. This is a valid statement. Now we will see the next topic. What is the meaning of feed control? Now, whatever we are discussing now, that will be coming in that will come in the short answers time. They will write about the equipments, and now we are going to see the feed control, isn't it? So these are all big questions. The major questions which are there, they are there in the side direction equipment, and then the problems which you have done. And these are all big questions. Feed control. Of the operations auxiliary to the size reduction itself, control of the feed to the mill is most important. Yes, we know this because our aim is to keep m dot fixed. When we can keep m dot fixed, because power depends upon that. If you put more amount of the feed, the crushing machine will take more amount of current. Means what? If you are applying load, what will happen? The meter reading will move fast. All your fans, geysers, everything is on. What will happen? The meter reading will be very fast. Suppose if you close everything, only one or two lights are there, then the meter reading will go very slowly. Sorry. So hence what we should do is we should control the m dot. We should put the feed in the most appropriate way into the size reduction equipment, so that when we are going to put m dot as a constant, then definitely our estimator will have some sense. It will measure a value which is near to the reality. That is important. Then the particles in the feed must be of appropriate size. We have seen this point already. If we are having uniform sized particles, it will be nice. Okay. And then if the sizes are different, what will happen? We know that the problem. No? Suppose in the feed, in the jaw crusher, if you send 1 millimeter particle is also there, what will happen? Without taking any blow, what will happen? It will pass through it. And then it is passing through a machine which is doing some work, but crushing is not taking place. So thus we are supposed to send feed of appropriate size, which is remember, which is accepted by the mill. That is important, because we have a ceiling. The ball mill, for example, you take a Blake type of jaw crusher, unless and until the particle passes through the given opening, what will happen? It will not passing through it. If not, it will be staying outside only. So limitation is there. That is important. Then obviously they must not be so large that they cannot be broken by the mill. If too many of the particles are very fine, the effectiveness of the machine, especially intermediate crushers, grinders, is seriously reduced, because we are giving energy and the particles are simply passing through without taking any blows, because their sizes are very small. The V shape is not at all necessary. It is not at all coming and contacting the solid particle. Then it is waste. So hence the feed should not have heavier size particles. The feed should not have small size particles. The feed should have optimized size of the particles, which is specified by the crusher, so that we have some sense of crushing and our effectiveness will be increased. Remember, in our unit number 1, we have to differentiate between efficiency and effectiveness. Efficiency and effectiveness are two different things. We are supposed to understand them in our unit number 4. With some solids, pre-compression or chilling of the feed before it enters the mill greatly increases the ease with which it can be grounded. Yes. Suppose if the feed is if we are applying some force on it, it is pre-compressed. You send to the machine. We have seen so many times in our chemical technology that before the reactants are sent to the reactor, they are passed to the jacket of the reactor to pick up the heat of the reaction. Why? Because when you do this, what will happen? The heat which is evolved during the reaction, that will not be taken by somebody else, that will be used for increasing the temperature of the raw materials, which is a very good thing, energy consumption. So here also what we do is, anyhow we know that in a ball mill, in a jaw crusher, the mode of breaking the particle is by compression. So if you try to pre-compress the particles and then send it to the system, then the energy consumed will be less in case of the main ball mill. That is one aspect. What is the second aspect? The second aspect is we are supposed to chill the feed. Okay. Why? Because if the particle is exhibiting a property of destroying its characters because of emanation of heat, in that case what will happen? We are supposed to safeguard the material. So hence you are supposed to cool it. Or how to cool it? You can pump liquid nitrogen over it, or have a shower of liquid carbon dry ice on it, or you can put dry ice into the crushing system, or the entire size reduction equipment is having a circulation of chilled water or cool water, whatever it is. So our aim is what? Yes, because of the heat, the product should not be damaged if it is heat sensitive, especially if you remember, the manufacturing of Estlin, where we are using nitrogen blanketing. So there, what is the problem? You know what is the problem? There, to avoid the explosion. So like that,
we are supposed to understand the nature of the material, and then we are supposed to do the necessary action so that the point of crushing will be 100%. We get 100% efficiency in case of the crushing. Similarly, if the particles are able to elongate, as in the case of the plastic material, then of course we are supposed to increase the brittle nature of the material. How, sir? By cooling it. So if you cool it, what will happen? The elongation will decrease, and then the particle breaks into pieces. Then of course next step is what? They can be worked by some other methods, some other process we can use it. Then chilling of the feed before it enters the mill greatly increases the ease with which it can be ground. In a continuous mill, the feed rate must be controlled within close limits to avoid choking and erratic variation. What is choking, sir? Suppose if you are putting the feed in the jaw crusher and crushing is taking place. What did I say? In our laboratory, how you are going to put it? Yes, first you will drop the salt particle, and once you drop the salt particle, you will be hearing a noise. You will be hearing some sound. So before that sound is completed, that indicates that when the crushing is not taking place, you will hear only the functioning of the mill. The sound, mill will be emanating some sound. You will hear only that sound, but crushing sound you are not going to hear it. So before you stop hearing that, put the second particle, third particle, fourth particle. So if you are able to do this, that is an art. So if you are able to do this, what will happen? Continuously you are dosing the solid particles to the crusher, and then whatever the machine it is consuming the energy, that will be used for crushing, that will be used for creating new surface energy. No problem. But suppose on the vice versa, from the bottom, if you are not taking the solid particles, or you are putting at a stretch all the solid particles, then of course it is called as choking. And then because of the choking, what will happen? The machine has to do heavy duty to crush those jammed solid particles or choked solid particles, and thus suddenly it takes more amount of the current. So because if it is taking more amount of current, thank you, nowadays we have MCBs. Whenever the current is drawn through the system increases, automatically it stops the machine. Automatically it stops the machine. I hope in your houses you may be having MCBs. So when you try to draw more amount of current, automatically the fuse will be off. So then you have to stop that process and then go and put it on. So recently all MCBs are there. So I said that starters, I have shown the diagram of a starter, and I have shown you the diagram of a MCB which is there in our roll crusher. So this is the meaning of erratic variation. Means what? Consuming of power, because the current will be very high when it is doing heavy duty. So such kind of things should be avoided. That is important. Yeah, erratic loads, and yet to make full use of capacity of the machine. At the same time, we should not play with the instrument. You are adding one solid, then I said you will be hearing a noise, then the noise is over because crushing is over, the particle has gone from the bottom, then you will wait for some more time, you will add the second one. So in this case also what will happen? You are not utilizing the capacity of the machine fully. So means what? Dumping all the solids at a stretch is a sin. At the same time, reducing the flow rate is also a sin. Mass flow rate. Why? Because the machine is taking energy and then you are not using the solid, you are not sending the solid particles fully. Then results a problem. So optimization of MDET is very, very important. In the cutting sheet material into precise squares or threads into uniform lengths of forks, exact control of the feed rate is obviously essential. Means what? It is a it is a prerequisite. Imagine newspaper. Forerunner is the name of a company which manufactures this kind of machines. So many idlers are there. So at the end, what will happen? Human beings will not cut the paper. Machines will be doing the paper. So when it comes to a particular length, it will stop cutting it. So precise means what? Precision is embedded inside this kind of machines, where we call it as cutting machines. Then we have the next concept called as mill discharge. This is very important. Means what? How we have seen feed control. Now we are going to see the mill discharge. Once the particles are coming out from the crushing zone, after the crushing is over, how we are supposed to take them back, and how they are going to come from different types of machines. Suppose if it is a batch process, of course, the operator will tilt the ball mill, and along with the grinding medium, all the particles will fall on a big screen, and then the grinding medium is replaced back. But in case of a continuous machine, how we are supposed to do this? Yes, statement. To avoid building up in a continuous mill, the rate of discharge must be equal to the rate of feed. So, in case of a jaw crusher or any continuous machine, how you are going to put the material at the same time, the particles should crush themselves and they should come from the bottom at the same rate. If any difference is there in between, that will be affecting the performance of the machine. Case 1, feed rate is high, product coming down is slow, accumulation will be there inside the system. Because of the accumulation, erratic variations in the load will be there. Hence, the performance of the machine decreases. Okay. The second one, what is the meaning of performance here? I am talking about energy conservation, the energy consumption, remember this. And the second one, if the m dot is more, or the feed which we are going to send it to the system is slow, and how they are coming down, they are coming very fast, then in that what will happen, we are not utilizing the capacity of the machine. So in that also, the performance of the machine will be decreasing, because it is giving energy but you are not utilizing it. So hence, we should try to equate the rate at which the particles enter the system is equal to the rate with which the product leaves the system. This is very important. Furthermore, the discharge rate must be such that all working parts of the mill can operate most effectively on the material to be reduced. This is very important. Unless and until, say for example, this is a beautiful statement. Is there any chance that the particle will escape the blows of the jaw crusher and then come down? It is impossible. This is taken care by that V shape. As the feed comes, if it is of same nature, then it will take the blow, breaks into pieces. Or else it cannot come down, it will be there only. Heavier size particle will be there only. If size is less, it will fall down. As it is coming down, the V shape ensures that again the particle will catch each other and then the crushing will take place. If not, the particle will stay there, take the next blow, and then size reduction takes place. Suppose in that case also, if it is more, then what will happen? In case of a gyrated crusher, we have a rotating crushing head is there on the shaft. What will happen? Apart from the compression, shear forces will also be applied and then the size reduction takes place. So it all depends upon the designing of the machine, which sees that at some point or the other, the forces will be acted by the machine on the object before it goes out from the system. That is the concept of design. Now, let us understand this by means of example. In a jaw crusher, for example, particles may collect in the discharge. In a jaw crusher, for example, particles may collect in the discharge opening and be crushed many times before they drop out. So, before why the particle is staying inside the crushing zone, that is important, because it is having a bigger size. It has to stay. Suppose if it has been crushed, all the particles are small enough so that they can pass through the bottom clear opening. Why the particle will stay inside the system? The gravitational forces will force it to throw out, because apart from that, there is a continuous displacement there. From the top, you are loading the particles. So hence they will be thrown out from the system. That is important. As mentioned before, this is wasteful of energy. In many of the particles are crushed more than the necessary. And one more example there. Since we are dealing with heterogeneous materials, a lump is put into the jaw crusher, but about size is small. Immediately what has happened? Its size was so small that in the initial height only it became very small. All the particles have become powders. What will happen? These powders, without touching the two jaws, which are gyrating at the rate of 250 gyrations per minute, they don't touch them, because with the bigger height only they are broken to small pieces. Please try to understand, on the line of application of forces, what is the concentration of material is important. I am repeating, on the line of application of force, what is the concentration of the material? I gave an example to you. Chalk piece is given to a small kid, he will break it into two parts. Chalk piece is given to me, I cannot break it. Why? Because I am catching the chalk piece in a lengthwise. Whereas the small kid is carrying it in the sideways. Without doing much effort, he will break into two pieces. Now imagine you are carrying the chalk piece in your hand in the lengthwise and then apply the force. You can imagine, because on the line of application of force, what is the concentration of active mass is important. Because it is the material which is absorbing the energy which you are doing it. So that is important. So in the initial stage only, if the particle is breaking, then fine particles, what will happen without touching them? They try to come. Means what? Here we'll see one more point. Orientation of the particles through the crushing zone is also very important. How we are charging them. You charge them such that the narrowest opening is passing through the clear opening. That is important. So this point elaborately we study in our fourth week. Don't worry about it. So how you are putting the material. So chalk piece, if you are putting, how you are putting? Put it vertically. When you put it vertically, immediately it breaks. If you put horizontally, then what will happen? Then it takes some amount of time. Crushing will take no problem. It takes some amount of time. That is it. Operation of a crusher in this way is sometimes deliberate. It is known as choke crushing. So when the choke crushing will be there, when the feed rate is there and the product discharge is also there. Product discharge is very less. Feed rate is more. In that case, it is called a choke crushing. Usually, however, the crusher is designed and operated so that the crushed particles readily drop out. Perhaps carry some oversized particles which are separated and returned. This kind of operation is called as free discharge crushing. What is the free discharge crushing? There is m dot, that is the rate at which they are entering is equal to the rate at which they are leaving. That is there. So in that case, what will happen? The particle enter, crushing is over, smaller particles will immediately come down. If the size is more, they will stay back. Their V shape is there, it will catch the particle, apply the force. So successfully the design, whatever we have designed the system, that will be utilized by the particle and then size reduction takes place. So in that case, accumulation is not there. When accumulation is not there, then of course it is called as free discharge. So what is choke crushing? Because of the accumulation, the choke crushing will take place. Choke crushing is used only in unusual problems, for it requires large amounts of power and may even damage the mill. So if the materials are not discharged properly, or say for example, if a foreign particle has come in between, then of course you know what is going to happen to it. You put your material continuously from the top, but that is not subject to the crushing. With fairly coarse comminuted products, as from a crusher, intermediate grinder, cutter, the force of gravity is sufficient to give a free discharge. Just now I said force of gravity. Once crushing is over, why the particle will stay inside the system? Already you are putting particles continuously. So because they are having some amount of mass, they will be traveling from top to bottom. So this is there in our primary crushers and secondary crushers. But in case of a micro atomizer, no, because the size of the particles is small. So we are not at all focusing our attention on gravitational force. But instead of that, what we are doing? We are using air. We are blowing air so that this air will carry the small particles from the crushing zone. Means what? We are supposed to have a separate facility for removing the particles from the crushing zone in case when the size of the particle is very less. That is important. Feed is very less. But when the size of the feed is what? It's the gravitational force which will take care of the problem. With fairly coarse, the product usually drops out of the bottom of the mill. In revolving mill, it escapes through the openings in the chamber wall at one end of the cylinder called peripheral discharge. Now, what is the peripheral discharge? I will show you here once. Yeah, this is peripheral discharge. So this is our ball mill, and a ball mill we have in this kind of openings. Okay, so these are called as, means what? The shell of the ball mill itself is made up out of a screen. So inside you will have the spherical bars, and this will be rotating. So what will happen if the size of the particle is less? It comes out from these gaps. So this is called as peripheral discharge. That is important. Okay. So from the in case of a rotating mills, we have one type of provision where we can transfer the crushed products can be taken out from here. This is called as peripheral discharge. Remember this. And then we will have Tunian discharge. Here we have Tunian discharge. I will also show that. Yeah, this is the small part. This is actually the covering of a ball mill. So these plates which are there, they will be preventing the grinding medium. What is the grinding medium? The spherical ball. So through these gaps, what will happen? The crushed product will be going up. So how this movement is there? Because you are sending the feed from left hand side continuously. So because of the displacement only, the solid particles will move and they try to go away. And remember at the center, which particles are present, sir? Here we have opening at the center only. Why? Because the size of the particle is less. What will happen? It will not experience any amount of centrifugal force and this will be displaced out from this opening. So this is the example of a Trunnion discharge. Okay, Trunnion discharge. Yeah. Yeah. In a revolving mill, it escapes through the openings in the chamber wall at one end of the cylinder. Now, so what will happen in the peripheral discharge? We have seen just now. On the shell side, we are going to have some screens. Okay, the shell itself is made up of a screen, so that if the size of the particle is, automatically it falls from the bottom, it goes out. Very good. One example I should not quote, but we know that we put Mugu in front of our house. So some equipments are available, small shells, small steel things are available. We put that Mugu and then we roll it. So what will happen? We get a particular design. That is the best example of a peripheral discharge in our domestic house. Then, or it is lifted by scoops and dropped into the cone that directs out of the hollow Trunnion. This is the Trunnion discharge, which you have seen in that ball mill. That means a sideways, from the sideways, the feed will be continuous, the product will be continuously going out. A slotted grate or the diaphragm keeps the grinding medium from leaving the product. So already we have seen in our ball mill diagram, a conical grate is present. Okay, so this conical grate, what will happen? It will be preventing the grinding medium to going out, because in rotation there is a chance that they may also go out from the system, but in a regular practice they should not go out. They should be present inside the system only. Peripheral discharge is common in case of a rod mill, Trunnion discharge in a ball mill and tube mills. So in the rod mill, what did I say? A rod mill will have a big cylinder. Converging part, diverging part are not there. Rods are present. So the crushing will take place only because when the rods are rolling over one another. So as the size of the particle is less, they come out from the peripheral discharge. On the vice versa, if you keep a ball mill, keep a conical grate so that it will prevent the grinding medium, but through the Trunnion, what will happen? The material will be discharged. Remember, the ball mill is held on a foundation. How? Because ball mill is rotating, foundation will not rotate. So means what? A Trunnion should also have a bearing with it. So if you keep a bearing, what will happen? One side of the bearing can be mounted on the wall. The second inside the bearing can be mounted on the Trunnion. So automatically it goes out. This is the example of a peripheral discharge. So last one. In discharging mills for fine and ultrafine grinding, the force of gravity is replaced by the drag of the carrier fluid. So in our diagram, we have seen air. Air was deliberately sent to the crushing zone by means of fans which are built inside the system. And this air will carry the fine particles B to A, they are passing out. A to B, the heavier particles will go out from the center, they take the blows of the hammers. And once the size is small, then only they will try to move along in the direction of B to A, because air is moving from B to A through the small gaps, veins, separated between the veins and the casing container. So the air we are using for taking out the product from the crushing zone. Then the fluid may be liquid or a gas. Wet grinding with the liquid carrier is common in the revolving mills. It causes more wear on the walls and the grinding medium than the dry grinding, but saves the energy, increases capacity, simplifies handling, classification of the, my goodness, these many things are there for the ball mill. So just till now what we thought that ball mill is in the ball mill we are going to pour water only to see that the displacement of the solid particle will be there. It will not hide in between the voids. It comes out, takes the blows of the ball mill, grinding medium, and then the crushing will take place. If it is doing so, then whatever the energy we give to the ball mill is going for crushing. That is the meaning of it. See, it causes more wear. But what will happen since water is already the surface is subjected to torture? Which surface? The internal surface area of the ball mill is subjected for torture because of the rolling of the balls continuously, which you have seen in the video in the beginning of this class. Suppose if it is a rod mill, it will be pronunciation will be more. Now if you put the water, what will happen? Again, the two phases will be there. Solid will be doing the work, and even the water will also try to shear off the solid part, the middle of construction. It causes more wear on the chamber of the walls and the grinding medium than the dry grinding, but it saves the energy because we are picking up the solid particles from the gaps of the grinding medium and then bringing it to the vicinity of crushing. Thus, energy increases the capacity. We can accommodate more amount of solid particles. Simplifies the handling. Yes, why simplifying? Yes, because our process of size reduction is successful. We are able to get desired size. One example I'll give you. You are having ball mill. One person is rotating for 1 hour. Second person is rotating for half an hour. Both are getting same product. What is the question of running for extra half an hour? It is wastage. So from this, if you pour water, we are able to draw it out from the system. We are able to bring out the solid particles from the gaps because of the displacement. And then we are taking that solid particle to the place where the side balls are falling on their heights. And then the classification of the product. What is the classification here? We are using is centrifuge classifier for separation of solid particles. Now, this is about the ball mills if you are operating in the water. A sweep of air, steam, inert gas removes the product from the attrition mills, fluid energy mills, and many of the hammer mills. So we are because there we can't assume gravitational force. Why? Because the size of the particles is very small. Because the size of the particles is very small, the mass of the particles are very small, the presence of the gravitational force on them is very minute. So hence we are supposed to use additional mechanism, some other mechanism to take out still further, because the feed itself is small. Then after crushing is over, what will be happening to the fate of solid particles? Even they are also small. So hence we should use a medium like air to take out from the system. The powder is taken out of the gas steam by means of cyclone separators or back. So now once they are out, what will happen? What is important for us? The solids are important. So on a continuous basis, if you want to remove them, you can keep a cyclone separator. Solids will fall from the bottom. The gas will go from the top, which can be recycled back. Or if the concentration of solids is less, we can go for the back.